Hi, this is the my project presentation of live attention detection in online classes. We all remember days when teacher used to go out for 2 minutes and all students started laughing, giggling. That was when there was continuous monitoring over student, but due to some reason it was shifted for a few moments. The student used to get diverted. So attention detection is really important in online classes because there is no such monitoring available. In this presentation, we will be covering background, the motivation, then technologies, then workflow, then results and references. The background, the trend of online learning is increasing at an exponential rate. We all know the COVID crisis has contributed to it. Uh, the online learning lacks monitoring. Monitoring is integral part of good and efficient learning. When there's no monitoring, students tend to behave insincerely and attend the classes just for attendance by logging into the system and doing whatever they want, not actually learning or gaining anything. So that was the motivation behind this problem. Problem definition. We expect a solution at the end of the project which monitors and report candidates attention of candidates in online interaction, but it's not limited to this. The point is that we are aiming at certain goals too at the point which are scalability. The program should be for work for 5 candidates and it should also work that efficiently for 1,000 candidates. Like uh, the server load and everything should be efficiently managed. Privacy and security. We are all aware about the backlash Zoom faced recently due to privacy and security thing. So we are expecting a solution that doesn't compromise with privacy and security at any point of time. Cost effectiveness is must because we are looking for scalability. When we are looking at large audience to reach the product to the last person in line, our solution should be cost effective. Platform independency is must because there are various platforms like Google Classes, Zoom. Universities have their own portal to give lectures, so it should be integrated. It should be able to work with any of those. Proposed solution. We are proposing a solution in which candidate logins at the start of lesson and logouts at the end. During the lesson duration, his behavioral characteristics like his looking direction and various other things are captured and sent to database. We are using Python 3 for facial recognition and visualizations and MongoDB for database. MongoDB was used because the cloud tier of database was free and it's easily integratable with Python. Feasibility study setup cost. As we discussed, for scalability, setup cost should be low, but at the for cost effectiveness and scalability, setup cost should be low. But that was from a candidate perspective. From organizational perspective, if we see, because the key audience is organization will distribute this software to its candidates. The setup cost should of organization should not be very large. So the infrastructure cost of organization is only the cloud data cost. It's estimated to be max of 1 MB per candidate. It's why so low. We will be discussing it ahead. Highly scalable and respect privacy. This describes the previous thing. We are not taking the snaps to the cloud. We are taking the snaps, extracting the features, and taking those features to the cloud. So the cloud data of candidates is really lightweight and which reduce the setup cost and maintains the privacy and scalability of the system. Limitations. We all know since the only we are not relying on any external hardware, we are using laptop webcam as the sole hardware. The quality of laptop webcam is not great, so a candidate is strictly advised to be in good light to have good protections for admin side. If we try to understand the workflow, see, there are end users working in online lesson together. Whatever the user does, where it looks, what he speaks, is his system on mute or not, is the person talking. And authentication is key. Like if the lesson is for me, no one is attending instead of me, and timestamp to compare at which instance the user showed this behavior is sent to the admin cloud panel. Next, if we look the admin can fetch the searches and get filtered results and view the results in form of reports or visualizations. The key module of client side were capturing live image to extract features, performing facial recognition that only if the lesson is for me, I'm in the lesson, no one else. Extracting direction of looking during interaction, that if I'm uh, starting the lesson, I'm not seeing anywhere else or doing any other thing. Checking if systems candidate on mute, that's that I have not put my laptop on mute, I'm doing something else. Extracting lip movement, that I'm not talking to someone else and I'm strictly focused to the lesson. Admin panel had ad candidates. Since the intended audience was organization, we didn't had external sign up form that would have posed security risks. Visualizations of candidate behaviors with parameter tweak like batch size can could be tutored. We will be discussing this in more detail in the demo. Generating reports from database. The database could generate reports and in form of text too. Working prototype, we will be discussing it in few minutes. This is the results. Like we can see that test 84, the orange candidate looks center of the screen only for once in the whole 20 duration. So it's intuitive that his attention is diverted from the entire group. Like blue one is looking for most of the time, green one is also looking for maximum of the time. The conclusion, this solution could also be employed to monitor employees during work from home scenarios. When admin panel is started, it takes some time to fetch database, to fetch the data. Optimizing it can be good thing for user experiences. Making the solution in low light could be a better goal. Like we could perform some image enhancements in the beginning and then do the further things. References. When I studied earlier papers, I got this problem has been addressed, but the solutions were either too invasive, like China introduced focus headbands that would that faced backlash all around the world, thinking it to have a look over what candidate is thinking. The solution was considered too invasive, and the lack of scalability was in maximum systems. Like they needed too much things to extract database, so from they could be a good option for 50, but going from 50 to 500 was a challenge from them. Other the attention softwares were not as popular as the attendance ones, and we are presenting both the solution in ones with scalability and everything. That's what we are trying to do differently here. Now we are open to discussions.